Hey everybody, this is Emmitt here for Suncast Media at NAPSAP 2025. We are in Reno, Nevada. If anybody knows me, and everybody typically does know me, they know that I like to hang out with friends. These are people that have been in the industry and know the ins and outs, and one of my friends is Chris Barrett. How you doing?
I'm doing well, Emmitt. How are you doing today?
Good. You know, I'm a fan of Yotta.
Yotta, yes.
Now, Yotta is not, it's actually a unit of measurement.
Actually, it means 10 to the 24th power. When the company was first formed, actually, it was the largest recognized SI unit in the world.
I didn't know that till I got a shirt that had the 10 to the 24th power. I wore it in public and people were like, what's a Yotta? I'm like, it tells you right here, but it's also a manufacturer of energy products.
Absolutely.
But your energy products are a little bit different in the fact that they are commercial and they're rooftop and non-centralized. Do I have that right?
You absolutely have that right. So what we tried to do is actually take the kind of microinverter concept and apply it to a battery. So kind of decentralized. Instead of having a centralized system where all the conversion is happening, we're doing it on the roof now.
Okay. So with that, that's one of the things that kind of got me, like, made me go, have a Scooby-Doo moment and go, huh?
Yeah.
Because, you know, one of the stipulations that you typically run into when you're putting things on a rooftop, particularly in commercial, because it's basically wide open. You have a TPO roof that is white, that is reflecting, so you're going to get heat in areas. That's why bifacial modules are such a good thing for it.
Right.
How is it that you were able to overcome some of these obstacles with putting these localized, decentralized units at the module level?
Like I said, we took the lessons learned from the microinverter world. I mean, think about it. 15 years ago, someone said, I'm going to put power electronics on the roof. You kind of chuckled a little bit and you said, this doesn't make any sense.
Right.
15 years later, it's kind of the mainstay in all of residential.
Yeah.
And it's actually working its way into commercial at this point.
Okay.
What we did was take the technology and try to encapsulate the battery technology in what, like basically a thermos. Think of a thermos in the morning. You fill up the thermos with coffee.
Yeah.
And open it up again at 11 o'clock in the morning. It is still piping hot.
Yeah.
Right? What we've done is actually taken that same technology and applied it to our product. So what we've done, in the thermos environment, it's actually basically a vacuum is pulled between the outside wall and the inside wall.
Right.
Vacuum is a very poor insulator. I mean, very good insulator, poor conductor of heat.
Okay.
So what we're trying to do is on our units, we actually use a vacuum packed ceramic board around all 6 sides of the battery packs. So we want to prevent any kind of heat that's outside from getting into the device. Any kind of heat inside, we can actually deal with that. You should either use it to keep the batteries warm, or if we need to, we can actually warm them with internal heaters as well.
But this is not just a battery, because you have a microinverter, you have a BESS system that integrates together as a total package, correct?
That's correct. That is
now,
correct.
This is for 3 phase. This is for 480.
480 Delta, 480Y. We also do a 208Y.
Okay.
And also a 240 Delta and 240 Delta High Leg. 4 different power configurations.
I was going to ask you about this. What about transformer integration? Do you have to have a dedicated transformer? Are there any ancillary items that you're going to need? Or is this a different approach on rooftop commercial solar?
No transformers necessary because it's all built in. It's native 3-phase product. Phase monitored, phase balanced right out of the box.
What about switch gears? You need any of that stuff?
Standard switch gear. Basically what we're doing is, for example, a 480 volt system, Y, for example.
Yeah.
You can run up to 11 inverters in one particular string.
Okay.
All of that goes down to a 3-pole, 30 amp single throw breaker. Simple solar.
You said 30 amp?
30 amp. 3-pole, three-pole single throw.
So this is different. And now you don't have to have a centralized inverter that's putting a lot of physical constraints or weight at a certain point on your roof.
That's correct. Distributed throughout the roof.
You don't need these heavy transformers that you may have seen in the past that are taking you from one level to another with switch gears and things of that nature. And then you have integrated communications as well, correct?
That is correct. So what we utilize for that, we actually utilize Zigbee communication.
Okay.
So Zigbee is a wireless communication, very similar to Wi-Fi. It communicates on the same exact frequency, 2.4 gigahertz.
Yeah.
Has the same range, about, it's 100 meters, about 335 feet or so. That's maximum. But the difference between Wi-Fi and Zigbee, Wi-Fi, for example, is what they call a point-to-peer. So like if your home or business, your computer talks to your router, your phone talks to the router, your Roku box talks to the router. Where in this particular case, the Zigbee adds the extra element of the peer-to-peer communication. So for example, I'm right in front of you right now and I say, Emmitt, what's the weather going to be tomorrow? I can see you, but you can't hear me.
Right.
I'll ask our neighbor here. Hey, ask Emmitt what the weather's going to be like tomorrow. So I can speak through all the different nodes on the roof, which happen to be all the different inverters and battery packs.
So what are the limitations of that? Because if you're on a commercial roof, you're going to have air handling, air exchangers, you're going to have a variety of things. You might even have a transformer that's not related to your stuff, but these all block signals because they're typically made of metal. There's interference. There can even be antennas up there. Are there any issues with that when it comes to that communication?
Of course, I mean, there's always a chance of that happening. But like I said before, the more nodes you have on the roof, the more chances you have to be able to communicate. Let's just say there is a large obstruction in the middle and the gateway is here and you're trying to communicate to an inverter across, but behind it, they will talk through all the inverters to get to the one in the back.
Oh, it's kind of like my family reunion.
Yeah, it's basically a mesh. Yeah, exactly. It's a healing mesh network.
Okay.
So I'm going to talk to you no matter what, one way or another, but I may talk to you through many different inverters to get my information, but I will get my information from you.
So that comes into play, that's a good factor when it comes to like rapid shutdown, making sure that you're compliant on the roof because you can always access that device that may be the furthest away.
Well, actually rapid shutdown is built into the device itself. So you don't even need communication. So if there is an event, if the AC is pulled,
that's right.
It's done in 1/10 of a second. It's touch safe.
Now, with the microinverter, how many modules are you feeding into a particular microinverter?
4. There's a 4-port microinverter.
So one microinverter covers 4 different modules that does the rapid shutdown for those. So now you're compliant for the 80 volts between 2 points as well?
Correct. Everything on the roof is touch safe as soon as the AC is pulled. All rapid shutdown and touch safe compliant within 1/10 of a second.
Okay, now I've seen this device is pretty clean. It's a nice little white box with insignias on it and everything. What about grounding?
Grounding is all done right through. It's on the device itself.
I saw your video, by the way.
The device actually has 2 different locations to ground. So there's actually a weave built in on the handle itself.
Okay.
That would ground right directly to the racking. If your AHJ requires an external wire, there actually is a grounding lug on the outside as well.
So that qualifies for your bonding and your grounding at the contact point where you're putting it on your racking, correct? And a lot of these are on your racking, you're going to have ballasted racking. That's what I've seen for the most part.
That's our mainstay. That's our mainstay because our mainstay is all CNI. Flat roof CNI.
Okay.
We do standing seam, of course, but we also do a lot of the flat roof TPOs.
All right, now I'm going to ask you, this is a very simple question. Looking at the industry where you are today, what is your advantage over these? And it seems obvious to me, but what are the advantages of going with Yotta versus some of the other traditional distribution offerings that are out there?
I think number one, it's going to save you money overall. I like to think about how the setups are going. As far as dollar for dollar, pound for pound, I kind of view our product as kind of like an iceberg, right? There's ours. But what's below the waterline is kind of the intangible things. Like, for example, with a Yotta system, I don't need to put a foundation in. It's not an AC coupled system, so I don't have to have separate permitting for it. It's a DC coupled system.
Oh.
I don't need any fire suppression systems because it's not a large battery system. It's under 3 kilowatts, which for NFPA 855 requires, anything above 3 kilowatts requires fire suppression.
Okay.
Ours does not.
So is it 4-to-1 regarding the battery system? 4 modules to 1 battery?
4 modules, well, it basically works as module to battery to a single port on the inverter. So you can actually load up
gotcha.
straight down. Right, exactly. So you can actually have 4, on one single inverter, you can have 4 batteries, so 4 kilowatt hours available storage for 1 inverter, and also 4 modules on top.
So I was looking at something, and you tell me if I'm on track. Because you're putting this underneath the ballast system, usually on a ballasted system, you have to weight it down. Does this contribute to taking away, adding extra bricks?
So exactly. So it is a ballast block replacement. The new Yotta block, here, is actually what we did was design it to be exact same dimensions and exact same weight as a ballast block. So it's ballast block replacement.
Oh.
So it's a zero net gain. You still got to put zero ballast blocks up anyways. Now you make it mean something. It's purposeful.
So you don't need as many ballast blocks.
Correct.
That you may have to crane up to a roof.
That's correct.
And transport across somewhere an eighth of a mile. So it saves you money in that front.
Absolutely.
So this is the first is this the first iteration or?
This is the second generation. Our first generation is called the Solar Leaf. It was a larger device, maybe it's kind of a suitcase-ish size. Yeah. So much larger. What we've actually done over the last few years is actually redesign this product and now call it the Yotta block. The Yotta block is in. That was the engineering goal. We set a goal to the engineering team, said, can you put this inside of this block? Because the change made a huge difference as far as racking compatibility. With the original design, we were very limited as far as racking, where we could put it on and where it could be used. But now with the Yotta block, it fits in any ballast block. With Solega boxes, we've got the Uniracks, we've got all of those different products that can simply plug and play.
All right, I'm going to switch gears. So now we're not on the roof anymore. A lot of industrial, commercial applications are ground mounts. How does this come into play, or does it come into play with ground mounted systems?
Absolutely does, and we have them all over the place. So basically with this particular device, the inverters would then mount on the racking, up on the roof.
Okay.
And then for the for the block itself, there's actually kind of a frame that would be sitting there. Would just mount up and would just sit in the tray, basically.
Oh, because most of the time when I'm seeing this at shows or when I'm researching you online, I'm seeing it on like the flat TPO roofs and seeing it from that perspective. But the one question that came up that I hadn't seen was, is there a solution for a ground mount? Because that's what I see a lot of in like my particular area.
I would say flat roofs is probably 80% of our business.
Okay.
20% is ground mounts, but it is done, and we have definitely plenty of them throughout a lot of California, actually.
Okay. What's one thing that you would want people to know about Yotta that they may not know?
What they may not know. We are the only rooftop distributed battery today. I believe that we are the cheapest solution for any kind of C&I storage.
Least expensive.
Least expensive, there you go. Least expensive. And it comes with a 10-year warranty, 10-year warranty of this and 25-year warranty for the inverter. The other nice thing about it is we actually have an online monitoring portal where you actually be able to see all this real time. You'll be able to see battery by battery, module by module performance of the system. And if there's any kind of issue with the system at all, you'll get notified of that.
So with that, you can see your state of charge, state of health. You can see your current voltage, phases, all that information.
All of that. And what's nice about that is if there is an issue, right? You can see it yourself as the installer. We can see it. We can help you and support you with it. I'll give you an example. We got a customer just recently, brand new customer. We worked with us for about 6 months or so, put in their first system. And after 3 months, they gave us a call and said, hey, love your product, but I had my first failure. And I said, well, let's take a look. So we were able to log into the system. And in 2 minutes, I was able to identify that it wasn't a Yotta Energy issue at all. It was a bad module.
Okay.
So for example, we were sitting on the screen, everything was producing power. One was producing 1/3 less power than the others. We were able to go into that one module, look at the voltages, and the input from that module was 24 volts, as opposed to 36 volts from the adjacent modules. I went to the installer and I said, hey, looks like you got a bad module here, not a bad inverter. And he says, I don't know about that. And I said, he rolled the truck. I said, I'm going to bring an inverter just in case. I said, you bring it, but you're not going to need it.
Yeah.
He went out to the site, lifted the module, took his multimeter and tested the open circuit voltage, and he got 24 volts.
Yeah.
He changed the module, problem solved. So the good thing is, number one, he knew about it, right? But the central system, that would disappear. You would never even see it. He knew about it within 3 days of the problem happening.
Oh, wow.
He was able to go out there and solve it. The other nice thing is because it was mapped properly, he knew exactly where it was on the roof. So we turned an O&M project from a 4-hour project into a 30-minute project, bringing the right amount of equipment to the job site.
And that's great for O&M.
Problem solved.
Well, I've got so many more questions, but you and I will probably handle that in one of my little other things. But Chris, I want to thank you so much for being on the Suncast stage.
Yeah, I appreciate
and being here with me. I am Emmitt Muckles from SE Power Consulting. This is Chris Barrett from Yotta. And we will see you at the next convention.
Thank you so much, everybody.